I, of course, forgot to turn on my mic. That would have been terrible. So, hello everyone, this is Chris Ingerson, and it is, I was going to say April, but it's May 2nd, and this is the May 2nd Text Quest Devstream. So, today we are going to be focusing on a bunch of timeline-related stuff. I should probably walk on screen, and I should probably say we're going to be doing coding and design, and not really art, I guess. Um, so, to start, I'm going to show you a look at the current setup. I haven't actually done anything in timeline yet. I've still been messing around with the tooling for this stuff, but I do have our iTween paths set up. So if we go over here to cutscene, we have wizard formation as our new cutscene. You can see that we have paths from all of these torches going up to specific points in front of the king. This is where the wizard is going to appear. So now, previously the wizard formed letter by letter from what were originally names of the royal family, but that was too confusing. People were, looking up at the fresco and trying to see all the names and stuff, and they thought that it had something to do with progression. So I just took that stuff out. It was too confusing for players to have it there. So the new formation is instead going to have the wizard form out of all the fire particle effects from these torches. So we're going to have them move basically out in a spiral formation until they get to a center point. Then they'll form sort of a cone around him, and then he will basically form out of the fire. And then we're still going to do the beard thing where he'll form without his beard first, and then he will form his beard essentially after he forms himself. A little bit of lag. It is going to be a little bit more of an over-the-top style cutscene. I actually have a bit of it storyboarded out, and essentially what's going to happen is it's going to be similar to the previous one in the sense that you're going to walk up to the throne, and right about here at the end of the carpet, you're going to trigger the cutscene, which will have the wall come up again, similar to what we did before, and then we will have the wizard form out of the particles. And since the particles are going to be coming from, all the way back here, it's going to be much harder for players to not see that something is going on. That was my chief concern with this. So it will be nice to not have that be an issue anymore. And once the wizard forms, he's going to be facing towards the king. And we're going to go for this very corny, very cheesy rotation where he'll turn around and snap. And that is going to form his beard out of these two torches up here. And then he'll turn around and snap one more time, which will start the magical vortex and affect the king. Do all that fun stuff. So probably what we're going to focus on tonight is going to be getting the particle effects functioning. So getting them lerping along these paths, as well as changing color, because one of the things that I would like to do is, these are all particle effects for the fire here. So if I select this real quick, and we're also going to end up changing this out a little bit. So this is going to be the particle effect we use. You can see it's got some orange, yellows, and reds in there to make it look like fire. When these rise and follow that path, I want them to change color after they cross the magic barrier. They're going to change to, I'm kind of in a toss-up if I want them to be red or like all red, or probably what we'll end up doing is having them be like pink, purple, and pale pinkish white. To match the color of the magic that the wizard uses. So you can see that we have this kind of like pink and sort of, I'm not going to say magenta, but more like a grayish purple. So the fire will basically change color once it reaches this midpoint, and then it'll form around and form the wizard. Because I would like to keep some color consistency between all of the spells that the wizard casts. So anyway, that's going to be the basic start, or the basic setup for what we're going to do. To go ahead and get started, I do need to finish some quick tooling that I was working on. One of the things that I was working on was, oh right, I moved a bunch of my scripts. So I have several clips for playing and adjusting particle system values. Now so the playing particle system stuff is pretty much done. Don't really need to do anything else there. I do need to add track clip type of, not play, but stop particle root system clip. Okay, So these two things will, well, play particles root system clip is already done. Stop particle root system clip is going to be really quick for us to finish up. I have the scripts created. I just haven't actually done the legwork to populate them real quick, but that's going to be a couple of lines of code. The adjust particle system value clip is probably going to be the thing that gives us the most trouble tonight because it's not finished and it's not going to get finished before this convention. And the reason that I say that, despite the fact that I'm 2 weeks out, is this adjust particle system value clip is so monstrously large. So the actual script itself is pretty basic. What's more difficult is this class. So let's go to definition. So particle system field is a serialized class that essentially holds data on what field you want to target out of all of the possible particle system fields, how you want to adjust its value, and the values to actually adjust it to. And it is all kinds of difficult to get set up. Mostly because I approached it from a more primitive state than I probably should have. I was passing in just raw values, start and end bool. Those are actually probably fine. Start and end float work, but particle systems don't really have a float value. They have what's called a min-max curve, and that's because they can be either like a constant float or they can be a float that's evaluated along a curve. And as it is right now, I don't really have a way of mapping the curve to the float values. So I can pass in my own values. So if you say that this is going to be, like the emission dot rate over time or whatever field, which is a float value, and then you set this set type to be lerp, you will get a start float and end float and then a curve at the bottom, which essentially does what the min-max curve does, except it's evaluated a little bit differently. There's a lot of caveats to this system. It's not quite where I want it to be, but it is functional for the most part in the sense that I know how to make things function, and as we need them, I will add them. Which of course means that probably afterwards and after the convention, I'm going to come back and redo it all so that it's much cleaner. But for the time being, I do have floats working. I'm pretty sure I have bools working. Yeah, I mean, in theory, I have colors, bools, and floats working, but it's all kind of weird. Actually, no, it looks like I just have floats working right now. Although I do have the code to get this side. And this is the problem. So the reason that this is such a daunting task is because, like I said, we have to have an enum value for every single module field. And if we look at this is something that took me forever, by the way, to do, because I had to do this by hand, which is stupid. I think there's like a couple of 300-ish lines of an enum value, or of a single enum that I had to populate by hand. And this is all of the fields that exist in particle systems. So it's separated by a underscore, which separates the module to the field, or the field to the module. So for example, culling mode is under the field, or under the module main, because every particle system has a main module. That's kind of the default one that you see at the very top. So it's a whole thing, and it is all kinds of complicated, and I don't have most of this set up yet. I do have the actual enum populated, and I do have a rough setup for how to affect these values, but I haven't actually gone about filling everything in yet, because it's just so many lines of enums that I have to check constantly. Anywho, to get started, we're going to go ahead and I'm going to run over to here. We want sleepyal.common.editor. Come down to here. We're going to go to, really, I have text quest under sleepyal.common. That's all kinds of weird. I don't really... Huh. Alright. We're going to go ahead and go to, let's see. Let's see, Sleepy Allsoft editor. And we're going to go to, oh, I bet that's just how assembly definitions are kind of wrapped in on each other. Let's see, this is under timeline. Timeline. And then tracks, particles, particle manager, core, this is where we are currently. So I'm going to change these clips, or these clip editors, to use a, let's see, I think I can probably just copy. I can just copy most of this. To use a base class, because I'm starting to have a bunch of these things, and it's just going to make more sense for them to derive from a single class. So we're going to go ahead and say using Unity Editor, using sleepyowl.common.types, not trim, timeline. Okay, this is going to be an editor, and we're just going to go ahead and paste this all in. It's not going to work right away, or I guess it would, except I don't need this field. Don't need you, and I don't need you. I do need everything else because of how it works. And we're going to go ahead and say custom property drawer type of, not custom property drawer, custom editor. Custom editor. I've been doing a lot of property drawers recently. Particle root system clip. Okay. Then again, that's kind of moot because this is an abstract class, but let's go ahead and say base editor class for timeline clips derived from particle root system clip. Okay. That means I can probably get rid of this because I don't really need it. We're going to change this to be protected. Protected, and then protected virtual. And that's pretty much all we need to do. So I'm going to cough. And then I'm going to come down here and say protected. Void draw base fields. Okay, and I'm just going to move this down to here. Paste this down here. We're just going to say draw base fields. That way I can draw that from child inspectors, should I choose to do so. Okay, I'm going to go ahead and save that. And that should be pretty much everything I need to do there. Let's go ahead and get rid of all of this. We're going to make this derive from particle root system clip editor. We're going to say protected override. We're going to call base.onEnable. Then we can get rid of all of that. And we can, again, basically just call draw base fields. Just do that, nice and simple. And that's all we needed to do for this particular script. So that's going to shorten up a fair amount of our code. And let's go ahead and do the same thing for play particle system. We're going to come up to here, paste this. We're going to get rid of type ID. So we can get rid of all of that and these two. Protected, not virtual override. And then we're called base.onEnable. Let's go ahead and get rid of, let's see, everything except with subsystems and stop on end. Okay, those are pretty much all we care about. Again, okay, so we're just going to do draw base fields again. Okay, so pretty straightforward. That should get our stop clips a little bit easier to work with. Let's go ahead and we're going to go ahead and exit out of here, exit out of here, and just going to let that compile real quick. Need to grab these and these, and we're going to add folder stop particle system, which of course will not work yet. Well, I could try to create something in there, but it's going to compile midway through. So we're just going to say initialize base fields, pass in behavior, and graph.getResolver. That should be good. Okay, so the base fields, by the way, are basically just the type which determines how a particle system is referenced. It's either going to be an ID, which is an int value similar to our sound manager stuff, where it just has a flat int value that it requests from a singleton. A direct reference, which is directly referencing a particle root system, and a virtual reference, which is referencing a virtual particle system, which is kind of like a wrapper that exists to basically spawn the particle system itself. And the virtual system is what the bulk of our stuff is going to end up using. We're usually not going to have a particle root system directly in the scene, because the entire point is to spawn them and despawn them at will. So instead what we do is we put virtual particle systems everywhere that we want particle systems to be, and then on start, we can tell them to request them, or we can just manually request them at a later date. And ID is pretty much the same way. You say, I want this ID, and then I want it spawned here at this position, and I want it to be parented or not. Pretty straightforward stuff. Okay, so what we need for stop particle root system clip is probably, I need to determine how I want to handle stopping it, because there are 3 ways that I could think to stop it, and that's going to basically be either, let's peek this, on graph stop, on behavior play, or on behavior pause. So on behavior play would stop it as soon as the clip starts, on behavior pause would stop it as soon as the clip ends, and on graph stop would stop it as soon as the graph ends. Pretty straightforward there. I probably should make an enum for that behavior, because I can see situations where I would want it to go either of those ways, really. So let's go ahead and let that compile. I'm going to go ahead and create my new editor for it too. So we're going to say stop particle root system clip editor. Editor. Is that right? Stop particle root system clip. Yep. Let's go ahead and open that up real quick, because we're going to have to edit it. Not right now, but in a little bit. And while that's happening, let's go ahead and select our wizard formation. And this is what it currently looks like. Excuse me. Interesting. So this is going to be virtual. Oop, and it compiled right as I did that, because it always does. So we'll give that a couple of seconds while Unity thinks about what it wants to do. All right. So you can see here that if we have this set to ID and we don't... Oh, really? A null reference, you say? How interesting. Let's go ahead and clear that out. Are we still getting anything? No. Ooh, but we do there. That's cool. Let's find out what that is. Not entirely sure what's going on there. Property field impair. Oh, right. That's not what it's called anymore. So let's rename this real quick. I changed it from parent transform to position. Position. There we go. Because when it was called parent transform, it was more indicative of what it was, the transform you'll get parented to. However, since parenting is an option, it feels better to call it position and then have parent be a separate thing. So this is now just called position. And that's pretty much all we needed to do there. So we'll go ahead and let that compile. And while I'm doing that, well, I say while I'm doing that, except I can't. There we go. Okay, let's go ahead and collapse this. We're going to say create. Yep, it compiled as soon as I did that. I knew it would. It always does. Okay, I knew it would. Let's see. So we're going to let that compile, and I think I'm just going to keep stop particles to their to the start of the clip for now. That should handle most of my cases. Okay, so let's see here. Now, stop particle system gets a little weird, although this does let me double check this. So let's set that back to ID. There we go. So you can see that if we don't have a particle manager in the scene, and we have it set to ID, it'll warn you that you don't have that. And then we can set our position and our parent. With subsystems basically determines if the particle system is going to play all of its sub-emitters. Most of the time you're going to want to check that off, but it's not necessary. Stop clip on end, or stop on clip end basically means that once the clip finishes up, it's going to stop that particle system. I wanted that to be optional. Originally it wasn't, but it's probably a good idea to keep it optional. That way I can kind of pass off particle systems from one timeline clip to another in a little bit more of an easy fashion. So we're going to set this up to be virtual. And since it's virtual, that means it's an actual transform in the scene, so we don't have to worry about position or parenting or any of that. Excuse me. Same thing for reference, although we're, like I said, not really going to make much use of reference. So I'm going to set it up to be virtual. We don't have anything set up yet for virtual particle systems, but we will do so in a little bit. Okay. So to do this, let's go ahead and I'm going to grab this. I'm going to select this. It's blue because, of course, it is. I'm going to put this right here. We're going to rename that to Candelabrum 2. I'm going to come over to here. I'm going to hit F. And I am going to be super mad. Give me a second. I actually need to right-click here and say, I'll just do this. I hate doing this with so much stuff in here. So we're just going to load up our splash fade scene real quick because it does have a reference to our client or to our game manager object, which will allow us to excuse me, to select from particle systems. So let's go ahead and we're going to come down to cutscenes again. Wizard formation. Oh, we don't care about that. Actually, what I want is this. So I'm going to delete this. Actually, no, I'm going to move this over so that we can see it. Okay. So I'm going to go ahead and delete this. And oh, I should not have done that because I need to do this. Create that game object right there. So that lets us have it in the correct spot. This is going to be called our fire. Should I call it virtual? Fire system. I'll do that. That's a little bit better. Okay, so we're going to make this be a virtual particle system. It is going to be fire. I probably should not be using my test cases here. So particle manager is currently using this, which is our test one. Let's go ahead and rename that. And I'm going to go ahead and just make a new particle manager or particle data collection. So let's see. We want to go to text quest and then data. Go ahead and say create folder particles. Okay, we're going to say folder intro create, and we're going to go ahead and just say well, I don't need that. Let's delete that folder. So I'm going to make create text or SOS particles particle collection. We're just going to call this particle collection castle. Okay, we are going to move this fire test, which is the exact same thing that this particle system is using. It's just isolated. Excuse me. Okay, I'm going to go ahead and create folder. I'm just going to call this prefabs. So I'm going to probably store the castle stuff next, or the castle prefabs for the particle systems next to the castle itself. So this is going to be a fun thing. So what this does is it basically lets you drag a particle system with prefab, or that is a prefab, into this little rect, and it will automatically handle upgrading the prefab to do everything that you need it to. So what we normally have to do is we need to have, if we look at the other prefabs, we need to have particle root systems and particle subsystems on them. And by dragging a particle system prefab into this field, it will automatically do that for us. So you can see that it handled generating the unique ID for it. We have the name. I'm going to call this not fire test, but like just Castle Candelabra Fire. Candelabra. I do not remember how to spell that. Let's see. Castle Candelabrum Fire. All right. I'll probably call it Candelabra. That sounds better. Candelabra Fire. All right. So with that, if you look at it, you'll see that it has changed. And if we actually look at it, you can see that we now have particle root systems. If we were to look at our debug information on these, you'll be able to see that these have unique system IDs, which is basically a way for us to determine what system something is. The root particle system always has a system ID of 0. Everything else is just kind of based on the order that it's found in. But they are all unique IDs. That way we can, if we so choose, play individual subsystems on a particle system without having to like chain through it to figure out which one we want to get. We can just, the root system knows all about its subsystems. It knows their IDs. So you can just say, I want to play this ID or this subsystem with this ID on you, and it'll be able to do so. Okay, so that fire test is there. I'm going to go ahead and rename this to be the same thing as its ID, which is just going to be Castle Candelabra Fire. Okay, let's go ahead. You can see that it's still here. All right, so I'm going to hit save here, and I'm going to I'm actually going to do this. I'm going to select this, and on this particle manager, I'm going to just straight up replace it with the actual particle system that we want to use, which will be here. Okay. And with that, we can come back to here, and we can select Castle Candelabra Fire. Okay. We do want it to play on start because it's just meant to be there. Now we can delete this. They should be in the same spot, so we should be good. Let's go ahead and delete that. Okay. And now I'm going to hit apply here after saving. I'm always concerned that it's going to crash once I do this. So we're going to go ahead and just hit apply. All right, nice. So in theory, that should spawn all of our particle systems as soon as the level starts. So I'm going to do two things. One, I'm going to delete this, and two, I'm going to reset this position. All right. So to test that real quick, I'm going to go ahead and just play in the scene. Let's go ahead and collapse all this. Before I forget, I suppose I should make sure that this isn't an autoplay. Cool. I'm going to go ahead and collapse that. Hit save, and I'm going to unload this. Okay, and I'm just going to go ahead and hit play. Maximize on play. So I should be able to just walk into the castle throne room, and we should just see particle effects like normal on the candelabra. If we don't, something horrible has happened, and if we do, then everything's golden. I know this is a little bit of a roundabout way of doing it, but it's mostly so that I can have a little bit more control over how my my candelabra, well, how my particles spawn in. Although now that I'm thinking about it, they might actually have the same random seed. It's super hard for me to tell. Because they might also have auto-generate random seed on, which will basically handle it for me. I just want to make sure that they don't look like they're doing the exact same thing. Which I don't think they do. I think they're random, yeah. But you can see that everything looks the same as it did before. So we have our fire up there. It might be a little bit close. That's fine. So yeah, you can see that we have our fire particle effects up here. I'm probably actually going to real quick. I want to see this. Fire system. Well, no, they're in the right spot. And of course they're static. Why would they not be? This is one of the other benefits of doing it this way. There's zero reason for these to be static. Okay. I'm sure that I just did that because the original ones were static. Which, of course, means I can probably go ahead and do this. Let's see. I'm assuming you're all marked as like light mapping, include static. I could probably just... No, really? Fire system is set up to ignore raycast? That's interesting. Does that mean that this was set up to ignore raycast? Why? Okay. That's weird. We can probably change that back to default. Okay, let's go back over to here. Fire system, let's just make this default. And that should pretty much be all we need to do. I probably, it's fine. Okay, let's go ahead and come back down to our cutscenes, wizard formation, and let's take a look at that. So now, if I wanted to get rid of this, I can reference these virtual particles. So I don't need to say play particle root system because we're already playing them by default. So instead, what I want is an adjust particle system value clip, which will essentially be doing the same thing. You can see that we have a little bit of some oddities here. It says false here, even though it's main duration. The only value that's currently set up to work with the timeline tooling here is, let's see, emission and then rate over time. Oh, okay, that time it didn't actually do anything. Hello, that's interesting. Oh, we have a null reference exception. Oh, that makes sense. These were all debug things. So I can probably just go ahead and do this. Okay, so let's clear that real quick. So the way that the adjustment works is basically we target a specific field on the particle system, and then the system figures out what values should be presented there for the user on the front end to determine what values need to be lerped between or set or whatever. Excuse me. So the main things that we're going to have to adjust are particle emission amount, which is how many particles it emits per second. So we're going to go ahead and change this to a virtual reference. We can change this to emission and then rate over time. You can see that it's now updated everything and it says 0. That's because our current target value is 0. We're going to set that to be a lerp value. And it's going to just evaluate along this curve for the duration of this clip. So I believe right now our starting value is 1.5. I'm probably just going to bump that up to 50, make it crazy. And we're going to hit save here. Now here is something that is not great. Currently this will only affect the parent root system, but I need to also affect child root systems, which means that I'm going to have a bunch of timeline tracks for this. And to get started, we're going to go ahead and we're going to do some fancy editor shenanigans, by the way, to really get this going. So first things first, let's see. This is going to be, I'm going to say, let's make it this starting one up here, which I believe is this, yeah. So we're going to go ahead and come back down here. We're going to reference this, select this fire system. Okay, it's referencing that. You see that it updated our clip name to reference the name of the object, as well as what our value is, and then what our target field is, and then what our values are going to be. So you can see that it says fire system. That's the name of the object. Emission rate over time. That's the module and the field that we're targeting, and then 1.5 to 50. That's the amount that we're lerping. If we were to change this, oops, come back here. If we change this from, let's say, from lerp to on start on end, you'll see that it changes to a vertical separator. If we just do on start, it's one of them. It's just the initial value. But we do want to lerp, and it is probably just going to be linear for now, I guess. All right. So before we can do really too much with this, we have to figure out a couple of things. One, we need to figure out how to set the color on our particle, and two, we need to figure out how to grab subsystems from that particle to actually handle setting the values on those systems. So this is going to be a whole thing. It is going to be quite interesting. I am going to have to figure out how we want to do this. So let's go ahead and I'm going to come up to here. We are going to not worry about the particle system field drawer, although we will probably need to be back. Let's see. Emission, excuse me. Color by speed, color over lifetime. Yeah, so the value that we're actually going to end up adjusting is start color probably for these. because we're not doing anything super fancy. But this is why it's complicated. So you can see that this is just a regular color, but I have the options of being a color, a gradient, a random between two colors, random between two gradients, and a random color. All we really care about is color or gradient, but I need to be able to make the determination about, do we want it to be a color or a gradient? And it gets very annoying when we have to do it that way. Anyway, so we're going to go ahead and let's go to adjust particle system value clip. We're going to go ahead and open this up. So we're about to get into some real crazy editor shenanigans, just to let you know. So this isn't actually doing too much, which makes sense because it's just storing the data. I am probably, let's peek this definition. I know I made this. Yes, it's the actual system. Good. Okay. So particle root system behavior typically looks for the particle root system, which is the base system, the one that's above all the other particle systems. But I need to actually make a version of adjust particle system value behavior that targets the specific sub-emitter that I want. And that means, actually, I don't have to make a specific version. I can just make it this class because I can make it a drop-down. It's going to be difficult, though. Okay, so we're going to come up to here. We have our field. I'm going to go ahead and serialize field. We're going to tooltip this. And I'm just going to say private int subsystem index. How about just system index? System index is equal to 0. So this is going to be the subsystem. Hold on. Subsystem hyphen there. System on the subsystem on the particle system. Particle system to adjust values on. Okay. And for this, what we want to do is I actually need to go to particle root system, which is not here. And actually, before we do that, let's go ahead and get our stop particle system stuff set up. All I need to do here is just pretty much let this go. We're going to come over to here. I do want to change, I'm going to say override on graph start. This is not going to call based on graph start. It's going to do nothing. Override to do nothing. Because we don't want to grab a new particle system if it doesn't exist already, because we're stopping it. And what we're going to do here is we're just going to change this from on graph stop. We're going to get rid of that non-behavior pause. We're going to get rid of that. We're just going to do it here. So I'm going to say, let me think. Ooh, crap. This actually did get complicated. So we're going to switch back to adjust particle system value clip because I need to get the system index stuff figured out. That way I can do the same thing for my stop particle system. So that I can stop individual particle systems if necessary, or I can stop all of them. Okay, so we're going to go ahead and let's see, what do I want to do here? Well, first things first, editor.timeline. We'll make this say using the editor, using sleepyowl.common.timeline. I'm going to make this be an editor. Oops, it's probably actually going to derive from particle system, particle root system clip editor. Just gonna let that go. It's not going to be completely done yet, but we're going to let it function for now. Let's see. And then some real quick stuff, which is just going to be if application.isPlaying because we only want these things to happen if you're actually playing the application. Real quick, we're going to peek this. So onGraph start should basically just be doing this, except we do have that problem, which sucks. Okay, that means I have to override it to do specifically that. So let's go ahead and grab this. And we're going to get rid of the ID stuff, because if we have an ID, we don't want to spawn it, because it makes no sense to spawn it just to stop it. Let's go ahead and save this, and all right. So now we need to figure out how we want to draw this index. because it is going to get super complicated. Let me think. How do we want to handle this? I suppose we'll have to do it through a custom editor. I was going to try to do it um, through a fancy fancy property drawer, but it's not looking super fun to do that because that would complicate things so much. Um, all right, so for now we can use just a custom editor to draw this, and I think it will work. At least it'll be easier for me to set it up that way. Let's go ahead and I'm going to copy this, move this over to this, go to definition, say public int system index. We're going to say behavior dot system index is equal to system index. Okay. And on this, I actually want to say system dot particles. We're going to go to definition. And I currently don't actually have a function in here to grab my particles with a specific ID, so we're going to pass it in. I've kind of been like adjusting these systems on the fly as I work on them, because they're not quite to the level of polish that I would normally prefer, but they're kind of being dealt with really quickly. Okay, so we're going to go ahead and say public particle subsystem get system, and then int ID. And all we're going to do here is say we're going to return null at the bottom. Otherwise, we're going to say for int I equals 0. I is less than system ID. I'm sorry, just ID. What am I doing here? Systems. Oh, this is in the particle subsystem. That's not right. Hold on. That's not where this goes. This goes in particle root system. Reference. Particle root system. There we go. System ID is pause to stop, initialize, play with subsystem, stop, pause, clear. Okay, let's go ahead and get rid of this. We're going to go all the way up to the top here, and I am going to just come down to here. Okay, so we're going to do that, and we're going to say systems, and actually it's called subsystems, I believe, subsystems dot count, capacity count. I plus and we're just going to go ahead and say, well, a couple of things. One, we're going to do a quick check before this that just says if ID is equal to 0, return this. Otherwise, we're going to go ahead and say if subsystems of I dot ID, our system ID is equal to ID, return subsystems of I. Pretty straightforward, and then we'll return null if it's nothing valid. All right. I'm going to go ahead and say particle subsystem, adjust particle value clip. This is setting that. All right. So we don't want to just say system.particles anymore. Now we want to say system.getSystem, system index. We're just gonna and then dot particles, because of course. So we're gonna do this. We're gonna go ahead and do this, and we're gonna go ahead and do that. Okay. So that should handle adjusting the values on it. Or rather grabbing the correct system to adjust values on it. And now we need to handle drawing it, which is where it's going to get super complex. System index. I'm going to want to set this up differently. Okay, so this is going to get all kinds of weird. We're going to go ahead and go over to, let's see, particle root system. Particle root system clip editor. I'm just going to put this in this root editor instead of having it be in individual editors below it, or that are derived from it, because it'll probably be easier to have this in a central location. So I'm just going to go ahead and say protected right. This is void draw draw system index. Yeah, okay, and this is going to take a serialized property, index property, and then that is pretty much all I want. I just need the index property. And I have to pass that because that could be named something differently each time, but for the most part, I think we'll be fine. I'm going to assume that the target particle system is always going to be either ID system or virtual system here. That's what I'm just going to have to assume for now. So let's go ahead, and what we're going to do is we're going to first do a switch statement. Say switch, and then we need to basically determine what our type is. So it's pretty much going to be this switch statement. So we're going to copy this, but then instead of these fields being drawn, we're going to go ahead and do this, and I'm going to add some extra spacing so that it's easier to read. All right. So this is our first step. Next, it gets a lot messier. So I guess I'm actually going to make this a bool as well. No. We're just going to make it a void. Okay. So if our target reference type is an ID, which means that it needs to go through the particle manager, we need to do a safety check, which means that we're going to have to say if not particle manager, particle manager, which means that this isn't using hfn.common, yeah, or not hfn. Too many namespaces. cpl.common. hfn is the company I work at. Particle manager dot exists. So if it doesn't exist, then we're just gonna do this. We're just gonna go ahead and say, let's see. I want this to be editor GUI layout dot help box, and we're just gonna say that and message type warning, and it's just gonna say no particle manager in the scene. Or how about, please add a particle manager to the scene to select particle IDs. That's a very long sentence, but I think it'll fit. Okay. Please add a particle manager to the scene to select particle IDs. Good. If it does exist, then we need to do this, which is going to be, so we're going to say particle manager dot. This is where it's going to get crazy. I'm going to do an instance dot get particle. Do I have get particle data? It's not get particle IDs. That's actually the particle unique IDs for all root systems, not for a specific system. And get particles actually returns the prefab, which actually it returns not the prefab, even the like an instantiated version of it, which I don't want. So probably what I'm going to do is I'm going to come over here, and I'm going to go ahead and say above that I'm just going to say public list int get particle subsystem. Well, how about get particle system IDs? Yeah, that's good. System IDs, an int ID. So this is going to basically say, how do I want to handle this actually? So we're going to say for int I equals 0, it's just going to be this basically. Hold on, let's see, get particle name. It's basically going to be this. So we're going to go ahead and grab this, paste that in there. So if this system has it, then we want to go ahead and not say get name. We're going to go ahead and say return new list int blah blah blah. Okay, and oh man, that gets so complicated. Let me think. So just having the IDs is actually not human readable, and therefore that's worthless, which means that I need to grab the IDs and the name of the object below it. So cool, that gets more complicated, which means that we don't want this to be a list of integer values anymore. Instead, we want it to be an array of GUI contents, because of course. So I'm going to go ahead and comment this and say returns an array of GUI content labels for use in editor scripts. Then the ID of the root particle root system to grab the ID of the particle root system to grab system IDs for. Okay, so this is going to return GUI content array. This is going to say new GUI content 0 for now. Actually, no, it's going to be 1 and then new GUI content. None probably would be the best way to do that. Okay, and what that means is that we're going to go ahead and say, if it has this ID, then we need to generate a bunch of this stuff. So we're going to go over to root particle system, and I need to add a call here that's basically just going to, again, be an editor-only function that's public GUI content get system index or IDs. And all that's going to require is that I say this. GUI content array labels is equal to new GUI content of subsystems dot count plus 1 because you got to include the root one. Okay, so we're just going to go ahead and say, how do we want to handle this? I think we're just going to go ahead and say for int I equals 0, I is less than subsystems, why will you not work with me, dot count, I plus plus, da, 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 da. And then we're going to go ahead and, at the very end here, we're going to return labels. Okay. And this is just going to be commented real quick. Returns AC GUI content array for representing all of the subsystems in this particle system, mostly for use in editors scripts. Okay. And then we're going to go ahead and say, we're going to loop through this subsystems list, and we're just going to say labels of I plus 1 is equal to subsystems of I dot, it's going to be ID. Yeah. This isn't going to work quite yet because I have to basically do this new GUI content and then string dot format, and then we're going to say this, if I could spell, and that, and then I'm going to go ahead and say, after subsystems, we want to say subsystems of I.name, and this is going to be 0-1. So it's going to show the index first, or the ID first, and then it's going to show the name of it so that it's easy to understand. We're going to go ahead and copy this real quick. Excuse me. We're going to say labels of 0 is equal to this. We're going to say just that and that. I suppose I'll add some this. This is these. What is the plural form of this? Because I kind of want it to be thises, or no, thises, instead of like this is. I don't know. All right. So we have that. That generates our labels. Now I can go back to here. Yes. And then I can say, oh my goodness, I still have to go through it. So we're going to say get system, and then we're going to say dot get system IDs. Yes. Yes, and I believe getSystem does not instantiate it. It should just like return the actual system value. Cool. And once we have that, which we're not referencing anywhere yet, so now we can go back to our particle system clip editor, and we're going to say get particle system IDs, and then we're just going to pass in mid.int value. Ridiculous. I need all of that just to grab my GUI content. And let me think. Man, there are some ways that I could do this efficiently, but do I value code efficiency or readability? Efficiency, I suppose. Okay, so we're gonna go ahead and say, oh, this is a whole thing. Okay, hold on. Oh, man. Yeah, that sucks. Okay, crap. Cool. Let's go to definition here. So this is going to be, let's rename this to get system ID labels. And then I'm actually going to go ahead and grab this because I need to also return an array of their IDs, the actual int IDs, because of course I do. Oh man, what a nightmare. Okay, returns an array of ints for use in editor scripts. System IDs for, yep, that's all good. I'm going to go over here to get system IDs, go to definition again, and this is going to be renamed to get system ID labels. And we're pretty much going to do the exact same thing, except for just the IDs, which I'm pretty sure I don't already have. Yep, not a thing yet. Oh man, editor scripting really makes this much more complicated. And the reason I'm going through so many hoops to get this set up like this is because it's going to, while it is a bit of a front investment, it will speed up our productivity immensely once we get the system in place. Okay, so this isn't going to be GUI content labels anymore. It's just going to be straight up ints. And we're just going to do this, and we're going to do this, and it's going to be this. Okay, and then it's going to be this. Okay, pretty straightforward. And then we can get rid of this, and I can just change this to IDs. Okay. Oh yes, this can be just IDs. Let's see, returns, an int array rep all of the subsystems in this system, mostly used for use in editor scripts. Okay, let's get rid of that. Okay, and now I can come back here and I can say get system IDs, and then at the end this is just going to say return new int with a 0 length. That's all fine. Okay, cool, looking good. Let's go ahead and bounce back over to here again. And now, so those are two things that I need. So I need to get int ID. So these are sub IDs is equal to, it's just going to be this. Except it's going to be get particle system IDs instead of ID labels. And then we're going to say GUI content labels is equal to that. It mostly sucks because I can't use these same names across multiple switch statements here. I just don't. You know what? Whatever. So I'm just going to go ahead and do this. So we're going to say int sub IDs is equal to new. Screw it. We'll just say null. And then at the bottom here, we're just going to go ahead and say int index. This is where it gets complicated. So this is a bit of scripting that I've done before. Basically what we're going to do is we're going to find the index of our current property IDs, which of course I made it an array, not a list, which is fine. Just means I'm going to have a for loop instead of an index of, whatever. So I'm going to set index up to be -1. We're going to go ahead and say for I equals 0, I is less than sub IDs dot length I plus plus, and we're just going to say if index property dot int value is equal to sub IDs of I, we will say index is equal to I, break. Okay, and then we're just going to go ahead and say if index is less than 0, which means that it didn't find its ID, we're going to set index is equal to 0, and then we're going to say property, index property dot int value is equal to sub IDs of index, pretty straightforward. And then we actually have to handle the dropdown, so the GUI part of this. So like all of this stuff was just preamble to actually getting the GUI. All of that was the backend stuff. Okay. And we still have these two things to fill in, but these will be much faster. Although I can do that real quick, actually. So if that's the case, if we're doing a direct reference, that's even easier because that means we can just do this. Sub IDs are equal to m system, I think, yep, dot exposed reference value, which I believe is an object. Yeah, okay. Wait, hold on. Yeah. And then all I need to do there is say exposed reference value. Really? Okay, fine. I thought that I could actually get the instance ID there. A couple of things. One, we're going to do this because I need to say return after this. And then for our direct reference, we're pretty much going to do the same thing. I'm going to say exposed reference value. I'm going to go ahead and grab this as particle root system dot get system IDs. Since we have a direct reference, I don't have to go through the particle manager for this. I'm going to go ahead and copy this. We're going to make this be the sub labels. Paste that in and say get system ID labels. And what we want to do here is pretty much the same thing as this, where we're going to go ahead and say if this dot get instance ID is equal to 0. That means that it's not referencing anything, so we're going to go ahead and say please assign a particle root system reference to select particle IDs. Same thing here. Pretty much going to do the exact same thing. Oh, man. Yep. Cool. So if it's virtual, we actually can't do this because we don't want to instantiate it, which means we have to do a couple of things. One, I need to go to my virtual particle system. Virtual particle system. Excuse me. Particles. I need to reference this ID, which of course means that I need to do this. Public int ID get return ID. Okay, so that is going to let us access that more conveniently, which means I can now go back to, oh man, too many things here. Let's go ahead and close this. Here we are. So if we're doing a virtual system, we essentially need to do like a weird hybrid of these two things. So I need to basically say, so I need this part first. And this is going to change to m virtual system. And we're going to say, please assign a virtual particle system reference to select particle IDs to select particle IDs. Okay, and then after that, if we clear that, we need to then check if particle manager exists, because of course. And then after that, we need to basically do this, but not exactly. So instead of saying MID int value, we now need to say m virtual system.get object reference, which is something that I actually cooked up to make it easier for me to retrieve things. So I'm going to go ahead and say virtual particle system. Okay, and then we're going to say ID. So that's what we have to have there. Oh boy. Okay, so that should properly process everything, regardless of if we're an ID, a reference, or a virtual reference. Okay, so now we code the actual GUI. All of that, we have, how many lines is that? 70 to 130. So that is 60 lines of code just as a preamble to actually doing the dropdown. Okay. So here we're going to say editor GUI. Yep. Editor GUI dot begin change check. And we're going to say if editor GUI dot end change check. Come over to here, and then I'm going to say index is equal to what do we want this field to be called? It's editor GUI layout dot pop up, I believe, and we are going to want a label. Let me be lucky. Dang it. Okay. Dang it. I was really hoping that I could pass in a serialized property here. Let's see, pop up. Pop up. We're gonna give me some integer pop up selection field, generic pop ups. Like, will you give me it? Yes. All right. So this is gonna be index property with labels and IDs. Actually, that works out quite well for us. And this is nothing, which might be fine. So I might not even have to do anything there. I might be able to just get away with that. Normally what I would do here is I would say something like basically index property dot int value is equal to sub IDs of index. But I don't think I need that anymore, so we can actually let that go ahead. And let's let all of that compile. That's not going to do anything yet because, of course, I forgot to do the most important thing, which is I need to actually tell it to draw this. So let's go over to here, find all references, custom editor. Okay, we're going to call draw base fields, and I'm going to go ahead and say draw system index, and then I need to actually pass in my serialized property, which I have not done yet. So I'm going to come over to here. So system index is the name of it. So we're going to go ahead and say private serialized property. That is equal to null. And then we're going to say that is equal to serialized object. Find property. That. Okay, let's go ahead and rename that as m system index. We're going to go ahead and come down here. And we're going to pass that in. And that should be everything that I need to do. So if we let that compile, it should, in theory, show up now on our particle clip there. So we'll give that a second. Oh my goodness, which means I need to change how this name is displayed. Ah, there are so many layers to this. I swear. The problem with knowing more about editor scripting is that you just start getting obsessive about specific things. This is fine. Yep. Okay, so that's going to complain because we don't have a particle system, so I can just go ahead and say, let's load this scene. That will load in our particle system, our particle manager, so I should be able to select it. Oh my goodness, all of that just for a fancy drop down. Oh, I could have easily just put in a freaking... Oh, whatever, it's fine. Okay, so that means that our index of 1 here, you can see that it is listed. So we have 0, that's our root system, and then our subsystems are all listed here. Just to make sure that this is actually being set, I am going to go ahead and click asset this. That should be at 1. Yes. Nice. Okay, let's go back here. We're going to go ahead. Ooh, you do not like that, huh? That's kind of funny. But it is understandable. Let's go ahead and go back here. You can see that we have, again, these are all being set. So cool, we can just set that up to be 0 because that's what we wanted. All of that for a fancy drop down. That's really all it was. And don't get me wrong, this drop down is cool because in theory that should work for ID reference and virtual references, and that makes it much easier for me to know exactly what I'm working with. Okay, so let's go ahead and save that. I'm going to clear this, and the next thing that I want to do is normally get obsessive and I would change this so that it actually shows, or not this, I would change this so that it actually shows the name of the clip, but, or the name of the system index, but I think we're just going to leave it there for now. So, oh, don't make me do it. Don't be obsessive about it, Chris. Okay, I don't need to do it. So I can go ahead and close some of these things. So adjust particle system clip editor at least is done. Particle system root, that's all good. So I don't need this anymore. I still do want the safety check up here though, because this basically just makes it so that if I were to change my target, my index won't stay at what it was. It'll reset back to 0 basically. Okay. Whew. Ridiculous amounts of code there. So let's go ahead. Yeah, this is ludicrous. Let's see. SOS particle system track. Just let me be obsessive a little bit and see what this would entail. Get particle name. Oh man. Yeah. Yep. Harumph. Harumph. We're going to go ahead and go back here, and I do need to, at the very least, make this public. So public int system index get return system index. Okay, and we're going to come back to here real quick. I'm just going to be lazy and do this for now. Because I do need something just to help make it visually apparent immediately what it's doing. Okay, give me a second here. Okay, and all we're going to do here is just say clip dot index is what it was, yeah. Okay, so we're going to go ahead and copy that, paste that. All right. So in theory, now, if we let that go, it should properly update this to say like fire system -0, which is minor. I'll probably come back later at some point to change that to be like -0 whatever the actual name is, basically match this label. But for now, I'm fine with just having some indicator so I know what the index is at the very least. Gotta let it compile though. It's taking too long. guess that means I'm going to do this. If serialized object equals null, return. Should fix that problem. Sometimes the timeline editor gets weird like that, where it destroys something after destroying the thing it's an editor for, and that throws those errors. It's kind of annoying. But yeah, you can see that it now says the name of the virtual system that we're referencing, dash, then the index that we're targeting with square brackets saying what field we're targeting on that emitter, and the values. Goodness, too much, too much. Okay, so the next thing is we need to set it up so that we can adjust color values on our particle system. I'm going to go ahead and select this. We're going to go to adjust particle value behavior. We're going to go ahead and go to this, go to definition. All right, so the thing that we want is to affect start color. So we're just going to go ahead and say case particle system dot main underscore start color. That's what we care about. Break. Okay. And from here, I am going to have to handle this. Give me a second here. Refresh. Field name. That gets handled in the drawer for this. So what we're going to do here is we're just going to say particle system dot main module. Main is equal to system dot main. Yes, and we can probably actually get rid of these because these are not doing what I want. This is the only one that matters. This is going to be a nightmare. This is going to be a nightmare. Okay. So we grab our main module, and then we're going to want to go ahead and say main dot start color is equal to color dot lerp from start color to end color based on curve dot evaluate from the lerp. That should automatically convert because start color is that min-max gradient, which means that it can be just manually set to be a color, which is honestly probably how I'm going to handle most of the time. So that handles actually setting these colors, but we need to now set up our, let's see, start, right, we don't have this working yet. So we need to say on behavior play and system does not equal null. Then we're just going to say system dot, oops, not that. We're just going to say system dot stop. Okay, pretty straightforward there. We can close that now. That still needs to be finalized, so we can leave that alone for now. This also needs to be cleaned up, but it's fine for there. Particle system field drawer. Yep, this is the monster. Okay, color. We're going to need to go ahead and say case particle system main start color. Just going to go ahead and do that, which at the end of the day means that we're going to do this. Copy this. We're just going to set you, and this is going to be type color. Okay. And that I think might actually be all I need to do. Switch. Oh, nope, we got to do color. Okay. So here we're going to go ahead and say, okay, actually it's going to be remarkably similar to this, so we're just going to go ahead and copy this for now. Copy this. Paste it in. It's going to be dot. Ooh, that did not work out. Dot color. Okay, set type. This is going to be start color. End color. Okay, color. And then curve. Okay. I think that's all that needed to be. Float color. Set type to end value. Looks like we're doing well here. Okay, I think that might be all I needed to do. Yes. So let's go ahead and let that compile. In theory, we should be able to add another adjust particle system value clip, and we should be able to target everything. And when we set our field to be main start color, it should properly update everything, and then we should see the actual color values here, and we should see them up here as well. Whew. Oh boy, that is utterly ridiculous. Okay. Still getting that null reference, huh? Still coming in at that weird spot. It's because this serialized object is totally not a thing. Great. There's a way to get around that error. I just never remember what it might just be checking the target, or if this exists. Anyway, I'm going to go ahead and say, so this is going to be, let's make a track subgroup. This is going to be for our, wow, this is going to be so many particle systems that I have to affect this on. Oh man, this is going to suck real bad. Okay, we can do this. So this is going to be Candelabrum 01. We're going to call this root emission. Okay. We're going to add a new sleepy out common timeline, SOS particle system track. This is going to be root dash color. We're going to add and adjust particle system. You'll see that that is not doing anything right now. An index out of range exception, of course, I did not take into account. I knew this was going to bite me, which means that I'm just going to have to do a safety check here that says if sub IDs dot length is, and now I'm just going to do this, is equal to sub IDs dot length is greater than 0, question mark. Otherwise, it's just going to be equal to 0. That's all fine. And here we just need to say if sub IDs dot length is greater than 0, then we'll show that. Otherwise, it's not really worth showing. I honestly would have thought, oh, it's because the particle system is 0, right? That makes sense, I guess. Let me think. Probably I should do this. So first we'll check if the particle manager exists. Then we'll check if the int value is not 0. So if that is equal to 0, then we're going to say please select a particle ID. And that means that we need to come down to here, and we then need to come up to here and paste this here, and then I have to do this. Woof. Okay, safety checks out the wazoo. And that means that I can also come up to here. This is no longer going to be a thing. I think I want to say if target is equal to null, return. Sure, that should work. All right. So we'll let that compile real quick. Probably I could select somewhere. Yeah, oh, don't do that. Yeah. Clear all that stuff out. Gotta give it time to compile. You can't rush these things. Unity is very sensitive. If you rush it, it just messes up. Okay, let's clear that out. I'm gonna go to wizard formation. No errors. Good. We're gonna select this. No errors. We get a nice little please select a particle ID. Good. Okay. Oh, this is a good time for me to test this, actually. Oh, yes, nice. It does generate them with the proper thing. Okay, we're going to set this to a virtual reference again. We're going to reference fire system. expose that property. Virtual reference. Why are you giving me these problems? Fine. Means I have to do this. It's equal to null. Fine, fine, fine. Which means that this also has to be equal to null. I don't know why I thought that the get instance thing would work. Probably it's because if I look at this, if I peek definition here, like we have, oh no, that's my safety check right there. Cool. Yep. All right. Well, there we go. So I was being overconfident. I misremembered my own code base. How embarrassing for me. Okay. So we're going to let that all compile. It is quite funny how I always think that I'm going to get way farther than I actually end up doing on a Devstream. I actually thought that we were going to get through all the particle stuff today, and I think we will get through all the particle stuff for one of the candelabras, but the rest of it's going to be pretty grunt work in the sense that I have to have I have to have 6 timeline tracks for each candelabra, one for each of the subsystems. Well, one for each of the subsystems emission rates and one for each of the subsystems color, which is, yeah, fun. Let's go ahead and clear this. I'm going to select this. We're going to set this to be reference. Hooray. Set that to be virtual. Hooray. We're going to set this to be none. We're going to go ahead and set this to be back to a virtual object. We're going to reference it here. You can see that we have all of this. We're going to keep it our castle candelabra fire. We're going to go to main and then start color. Nice. So you can see that that all came out. Goodness gracious me, that is not a great look there. It's going to be super long if I do this. Yeah, that goes right off the screen. Do I have, let's see here. Hold on. Particle system field drawer. Yeah, here we go. We're going to go up to here. I want to go to color. Did I make a 2-color string? I did. But I don't remember what. Yes, okay. So I think that's what I want. Oh my goodness, ridiculous. Well, that's probably all right. So let's just go ahead and call 2-color string on everything. I think this is similar to my 2-vector string, where I just have a much nicer format for these things. Because if it's 1.0, I have no reason to require to see 1.000. I can just shorten that a bunch. Okay, so we'll let that go. We are just going to do on start though, so it doesn't really matter too much right now anyway. And it's good that it does actually adjust to be a color. You can tell that because we are seeing our color fields here. We'll let that finish compiling because while it's in that state, I can't actually do anything. One of these days. All right, still getting that null reference, huh? Okay. Oh, hilarious! It's exactly the same. I must have set it up to try and look as much like theirs as possible, which I guess makes sense. Okay, so we're going to do on start, and I'm just going to set this color to be bright magenta, basically. Whew. Okay. So the next thing I need to do is, so that's particles. I'm going to go ahead and say, yep, we got to just do a new one. We're going to add sleepy.io common timeline. We're going to add an iTween track. We're going to add an iTween path clip. This is going to target the fire system here. And then it's going to require the fire path 1 here. Ease in out sign is fine. Okay, and what I'm going to do here is, let's see. I'm going to, I'm just going to set up a trigger to just start this timeline, and I'm going to try to offset this to be like here-ish. That's probably all right. Probably we could do. So that's 3 seconds. Yeah, okay. So we can shorten that. Emission over time. It's going to evaluate on that curve, which we don't need to worry about really. Okay, so I think what we're going to do here is I'm going to give myself a 1 second, let's do a 2-second delay so that I can actually look over at it. Our rates will quickly go up to 50 and then they'll come back down. Let's go ahead and set that up. So this duration is about 5 seconds, I think. Yeah, cool. So let's go ahead and close this. We're going to not preview it anymore. I'm just going to go ahead and add real quick an empty object to trigger this stuff. Okay, so this is going to be a trigger, which I think is a timeline trigger, which is hilarious because I'm pretty sure a cutscene trigger does the same. No, that does not do the same thing. That is something else. Timeline trigger it is. Player tag is what we want. Play once is what we want. Timeline is this, and we don't really care about debugging, so I'm just going to go ahead and add a physics system box collider. It's going to be a trigger. Oops. Let's go ahead and move this over. Put this right about here. And just to make sure that this is actually reachable here, I'm going to go ahead and let's move this up a little bit more. We're going to set it up to be 3. We'll give it a height of 6. Oh, wait, no. That is awkward, but I guess it makes sense. Okay, 4 with a width in the Z of like 10. Yeah, we'll just go all the way. All the way, apparently, is 30. Okay. That should trigger our... let's put that in Ignore Raycast as well. Let's give that a save. So that's that. Let's make sure that they're not hidden. Oh my god, they are like right inside of each other. Okay. That's fine. I actually want them to trigger at the same time. So, cool. Let's go ahead and give this a test run. And we should see this candelabra's fire basically move along and end up stopped here. We should see its color change, and we should see its emission rate change as well. Okay. Let's give this a shot. I'm going to unload this scene. Just save. Whew. Utterly ridiculous. That was an hour and a half of editor scripting for just this one test. Okay. Open. Keep an eye on this thing. There we go. You can see that it's... Yes! Yes! It did it! Was a little bit odd in its way of handling the movement, but I guess that's more down to iTween and my setup for it. Okay, so we now have... we can now adjust particle system color and emission rates via timeline in a generic method. So that is the first part of that cutscene, the very start of that cutscene. Oh man. Okay, so the next things that we would want to do is set up all of those particle systems to have their colors change, to have everything pretty much set up. And now that I think about it, because this is something I just thought about, these particle systems are probably, hold on. going? I bet that was doing something very stupid. This is something that I'm going to have to fix in my code here real quick. Torches. You were doing something stupid here, weren't you? Oh my goodness, you were. Yup. Yup, 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 yup. Okay, so that's got to change. Wow, I just do not. Okay. Yeah, we're gonna have to figure that out. I'm probably going to end it there tonight. Actually, it's a little early, but almost everything for the next couple of steps in this cutscene are all going to be highly repetitive work that I just have to handle. It's not going to be particularly interesting to watch. So I'm probably going to end it there. Some quick announcements. So I should be good to do a Devstream this Saturday. I'm gonna say that over the next couple of weeks, I might not be streaming as much because as I get closer and closer to a convention, I typically start kind of like zeroing in and focusing on specific things. And I typically get super focused on those things, and they're not necessarily interesting to watch. And more specifically, I tend to just work much faster when I'm not doing dev streams. So while I do enjoy doing dev streams, they do slow me down when I get close to conventions because I'm kind of like hopping back and forth between a bunch of different things, which is just confusing to watch. It's not particularly interesting to watch, and I work faster when I'm not really considering, is this something that's going to be interesting for people to watch me do. So over the course of the next week or so, or next couple of weeks, I may not be doing as many streams. So 2 weeks from tonight, I will be in Rosemont, Illinois, showing up at ASEN. Because of that, I'm not going to be doing any dev streams for that Thursday or that Saturday. I'll be tweeting and posting on Discord and all that. So if you're in the area, feel free to stop by the booth and say hi. But that's just something to be aware of. So about 2 weeks from now, I'm not going to be doing dev streams for about 2 of the days, so Thursday and Saturday. And that's pretty much it for tonight. So we got pretty far. We have the initial steps for our cutscene sort of in place, and now I need to get the actual timelines set up for adjusting particle values, which is just going to be insane. It's going to be so much, but at the very least, we do have nice edit. I mean that hour long setup for our timeline stuff. There's a reason that I did that. It's because now when I want to adjust these systems, I can just very quickly select my system and select a sub-emitter, and I can have total control over what emitters have what values adjusted on them. So that's going to speed things up in the long run because now I'm not going to be hand entering these IDs, and I'm not going to have to like animate these particle systems. I can just do it straight from code. So, all right, that is a pretty good place to stop for the night. So, as always, I want to thank you all very much for watching, and I will see you all next time.